Hey, this is Mr. Janes, and in this video we're going to be talking about naming angles. So in front of us here we've got a number of points and three angles. We've got one angle here, we've got one more obtuse angle here, we've got one angle here. If I asked you to pick one of those three angles and tell me which one you picked, it would be pretty easy. You could just tell me, oh, I picked angle B, I picked angle G, or I picked angle F. Now it's easy because each of these angles has a different vertex. Now the vertex is this point right here, from which the two rays, right here and right here, of the angle diverge. So this is called the vertex. Okay, and these three angles all have a different vertex. So you could say, I picked the angle of the vertex B, or I picked the angle of the vertex G. Pretty easy so far. But what if we had angles like this? In fact, there are three angles in this picture. There's one here, there's one here, but also this whole thing is one giant angle. So if I asked you to pick one of those three angles and tell me which one you picked, if you said, well, I picked angle G, I wouldn't know what you're talking about, because all three of these angles have the same vertex at point G. So that's not going to be enough. Instead, what we're going to do is use three letters to denote our angle. So for example, if you pick this angle right here, I'll make it green now, you're going to call it angle CGD. So this is angle, use a little angle symbol, CGD. If on the other hand you picked this smaller angle down here, well, that's going to be angle DGE. Angle DGE. Or maybe you picked the largest angle, right here, this whole thing, angle CGE. Angle CGE. In all of these cases, we've started by picking one point on one side, one ray of that angle. Next, we pick the vertex, kind of the point of that angle. And then lastly, pick another point on the other side of that angle, the other ray. So CGE would work for this biggest angle right here. Let's test this out a little bit. What if I wanted to name this angle right here? What would I call that? Well, I would call it angle GCF. Angle GCF. Because I'm starting with one side of the angle, a point on one side of the angle, so G, the vertex C, and then the other side, F. I could also call it FCG. FCG is just fine there, as long as I keep that vertex in the middle. What if I wanted to name this angle right here? This angle right here. Well, I could call it angle CGF if I wanted to. Angle CGF. I could also call it CGD. Now I can use D because I'm just simply going from one side of the angle to the vertex to a point on the other side. So either F or D is fine. So angle CGD is also a fine way to name that red angle. Now some books like to do this. They like to put a number inside of an angle to kind of make it easier to notate. So this angle right here, normally I would call CGF, it would be CGD, angle CGD, doesn't matter. But I could also call it angle 1, because there's a 1 right there. Similarly, this angle right here, I would normally call angle, I could call it FGE, keeping that vertex in the middle. But since they put a 2 here, I could just call it angle 2. I have that option, and some books like to use this. Let's go ahead and take some formal notes on what we just learned. An angle is two rays with the same endpoint. That endpoint is called the vertex. So right here, this point right here, A, would be the vertex of this angle. And this would be the vertex of this angle. Now, commonly, we're going to use three letters to denote our angles. I'll put the angle symbol first, then we'll call this angle CAB. We could also call this angle B, A, C. It doesn't matter as long as we keep the vertex as our middle letter right here. That's fine. If I try to write something like angle CBA, well, let's see, would that work? CBA, no, that would not work. That's not the same angle, and that's wrong because I'm using B as my vertex when really A is my vertex here. So that would not work. Got to keep that vertex as my middle letter. There are also a couple other options that we'll use sometimes. If you've got an angle that only has, or a vertex with only one angle, such as this right here, you can just call this angle A. Now if I added another angle over here, maybe point D, I couldn't do that because now I wouldn't be sure which angle it's referring to. But if there's only one angle by itself with its own vertex, you can use one letter. Also, if your angle is labeled with a number, like this one is right here, then you can just call it angle and then put the number. So angle 2 is fine. These are only used in very specific circumstances. When in doubt, use angle and then 3 letters right there. Next, let's talk about some different kinds of angles in terms of how many degrees they have or their measure. Go ahead, you've probably heard these terms before: acute, right, obtuse, straight, and reflex. So pause the video here and try and draw examples of each one. And if you can, actually describe them below your figure that you've drawn. Pause the video now. The answers will be coming up in 5, 4, 3, 2. Here are the answers. All right, so we've got, let's see here. We've got our acute angle with measure less than 90 degrees. Remember, acute things are small, so acute angles measure less than 90 degrees. A right angle with exactly 90 degrees. Perpendicular, we often call that. Obtuse angle with a measure greater than 90 but less than 180 degrees, because a 180 degree angle is a straight angle, and creates a straight line, right? Half of the full rotation, so 180. A reflex angle is anything over 180 degrees, but less than 360. In medical terms, if a joint is in reflex, then it's past its normal limit of flexibility. So if your knee's in reflex, you probably should go see the doctor because it means it's going backwards. All right, now that you've done that, let's go ahead and learn some vocabulary terms that you might not know yet. First up, 2 angles that share a side or have a common ray. Those will be called adjacent angles. ADJ, ACENT, adjacent angles. So here is a figure, or an example, of adjacent angles. So we have one angle here in green and one angle here in blue. These 2 angles will be considered adjacent because when we look at the sides of these angles, the rays, they share this ray right here that I'm putting in yellow. Both the blue angle and the green angle have this ray in common. So that would be considered an adjacent, or a pair of adjacent angles. On the other hand, if I have one angle here and another angle over here, these are not adjacent angles because they do not share any of the same sides, the same rays. Notice that this green angle has its own rays, and this blue angle also has its own rays. So this is not a pair of adjacent angles. Now here's one last example that's a little bit confusing. Imagine you've got one angle here and another angle here, and I'll label the first one in green and the second one in blue just like I did before. Now you might say these angles are adjacent because they have the same vertex, the same point right here, but these are not adjacent because this green angle has its own set of rays and this blue angle has its own set of rays for sides, and the blue angle and the green angle do not have any of the same rays. They don't share a side. So these are not adjacent. However, if we were to put an angle here, we could say that the green angle and the red angle are adjacent because they do share this ray right here, but the green angle and the blue angle are not adjacent. Our next 2 terms have to do with what the measures of 2 angles add up to. Angles with degree measures that sum to 90 degrees are called complementary, whereas angles with degree measures that sum to 180 degrees are called supplementary. So complementary, you can think of adding up to 90 degrees. So if I had a 90-degree angle, and I split that with a ray, like this, and let's say I had perhaps a 30-degree angle right here, and a 60-degree angle, these two angles would be complementary because when summed or added together, they create a 90-degree angle. However, in this example, they're adjacent, but they don't have to be. You could have maybe, I don't know, a 40-degree angle here, and a 50-degree angle over here, and 40 plus 50 is 90, so together, these two angles are also complementary because they sum to 90 degrees. On the other hand, supplementary angles are angles that sum to 180 degrees. So think about a straight angle. A straight angle is 180 degrees right here. And let's split that into maybe a 120 degree angle and a 60 degree angle. These two angles are supplementary because they add up or sum to 180 degrees. But just like before, they don't have to be adjacent. You could easily have a 100-degree angle and maybe an 80-degree angle right there. And together, these two angles would be supplementary because they add to 180 degrees. Now, it's sometimes hard to tell these apart, complementary and supplementary. So here's two ways that I think about it. One way, the letter C comes before the letter S in the alphabet. Since C comes before S and 90 comes before 180, complementary is 90 degrees and supplementary is 180 degrees. Another way that I like to remember it is this. When you compliment somebody, you're just giving them a good comment. You're saying a nice thing to them, complimenting them. But when you supplement somebody, you're supplementing their income, you're giving them something, a present, or you're giving them money or something like that. I would rather be supplemented than complimented. I'd rather get some money than just be said something nice to. And 180 is greater than 90. So that's how I think of it. Supplementing is better than complimenting, 180 is better than 90. There are two ways to remember it, whichever way you'd like, or just memorize complementary sums to 90 degrees and supplementary sums to 180 degrees. Let's talk about two more words. A pair of opposite rays formed by two intersecting lines. Well, what do they even look like first? So if I have one line here and one line here, the opposite angles would be here and here. Those are called vertical angles. Vertical angles. Okay? And one property we know about vertical angles is that vertical angles are always congruent. So if this was 80 degrees right here, then this angle right here would also be 80 degrees because they're vertical angles. We'll talk about why that happens a little more in class. This angle here and this angle here are also vertical angles. So for example, this was 100 degrees. This would also be 100 degrees because they are vertical angles. They're across this vertex from each other. So again, one angle, go across the vertex, this point right here, and you get to the other vertical angle that is congruent. Our last word is a pair of adjacent rays formed by one line and a ray. This is a linear pair. Linear pair. And so if I have two lines right here, okay. In the last example, vertical angles were across the vertex from each other. But in a linear pair, these angles are adjacent to each other. So, for example, these two. Now you might notice from before that these two angles in a linear pair will be supplementary. They're going to add up to 180 degrees. So a linear pair always is supplementary and sums to 180. So maybe this is an 80-degree angle, and this would have to be a 100-degree angle. Again, linear pairs are always supplementary. Before we go ahead and talk about missing measurements in sides and angles, I'd like to use these two figures. First, pause the video and see if you can find any adjacent angles in these two figures. The answers will be coming up in 3, 2, 1. There are many angles in these figures that are adjacent, but here are a couple examples. Notice how both examples here share a common ray. That's what it means for two angles to be adjacent. Next, can you find a pair of complementary angles? Pause the video now because the answer will be coming up in 3, 2, 1. Remember, complementary angles sum to 90 degrees, and we can tell these two angles in green sum to 90 because of the symbol right here. These two will add up to 90. Next, can you find a pair of supplementary angles? Here in blue are some examples of supplementary angles. you can notice that they create a straight angle, which is 180 degrees when put together. So you can tell they add up to 180 degrees that way. Next, can you find examples of vertical angles in these diagrams? Pause the video now. The answers will be coming up in 3, 2, 1. And here we have a couple examples of vertical angles. Of course, there are many more, but you can tell that these are vertical angles because they are across the vertex from each other, and they are formed by two intersecting lines. Next up, a linear pair. Can you find an example of a linear pair in these two diagrams? Pause now. The answers are coming up in 3, 2, 1. Here are some examples of linear pairs. Of course, there are many other examples here too. You'll notice that these are the same as the supplementary angles that I highlighted before. That's because since linear pairs have to form a straight angle, they of course have to be supplementary as well. Supplementary doesn't have to be linear pair, but all linear pairs have to be supplementary.